So the main objective of a VRF is to do what? Is to segregate on a local router, only locally significant. Everybody on the same page regarding that? Good. So once that's in place, now I have the ability to go ahead and take it to the next level where I want to secure it as well. So when the traffic goes between R1 and R2 for the red VRF, they have paid me extra money as a service to encrypt the traffic so guys in the middle cannot read it. All right, as a service, the service provider has provided the ability to encrypt the traffic. Now, if I encrypted the traffic, let's say on R3 towards R4, I could do a normal IPsec LAN-to-LAN tunnel, GRE tunnel, whatever type of tunneling I would do on R3, it would work. All right, because it's a normal routing table, the global routing table, right? But I want the service provider to provide that capability because I don't have the internal expertise to be able to do that. So I'm going to do a VRF over here, sorry, IPsec tunnel over here on this interface, which is E01 towards R2. Do you get my point? Do you guys understand what I'm doing? So that I can show you how a VRF works in conjunction with this. Clear so far? All right. So I'm going to do a simple LAN-to-LAN IPsec tunnel. And what we'll do with that is we'll take a look at the differences. So what I'm doing over here is VRF aware IPsec VPN. All right. So I'm going to do it on R1 for which VRF? Let's do it for red VRF. How would I go about doing it? You guys are experts at IPsec now. Step 1, normal crypto, Aiesec policy 10, auth pre-share, hash MD5, group let's say 2, encryption, triple des. All right. Normally, what do I do over here? Crypto Aiesec key, Cisco 123 address is, let's say 10.12.12.2, which is router 2, correct? Now, this is where the issue comes in. This is the main issue with IPsec VRF. What routing table would it look at when I do this command over here? Where would it look for this particular IP address? It would be in the global routing table, the default routing table, whatever you want to call it, right? I don't have this address in my global routing table. Is it this address resides inside a VRF, right? So that's where the issue comes in. Other than that, pretty much the same. So I'm going to ignore that issue for right now. Let's go back and take a look at the other configuration parameters, and then we'll come back and basically attack the problem with the key. The main problem is the key over here. So I'm going to keep it as is. And later on, I'm going to change it. So for right now, I'll do phase 2. Crypto IPsec transform set, key set, ESP triple des, ESP MD5, HMAC, step 3, ACL. My interesting traffic over here I want to do is, let's say, 10.3 to 10.4. Permit IP 10.3.3.0. Good. And number 4 is my crypto map. Everybody understand this? I'm not explaining it. I think this part should be okay by now. Good, everybody? Isn't that what I would do? And as I said, the only problem over here is what? The key. So they had to find a different way of attaching the key to the appropriate VRF, because by default, it looks in the default VRF. The default VRF is your global routing table. Okay. So what are the changes that I need to do over here? First thing that I need to do is I need to create what is known as an Aiesec keyring. In the keyring, I'll call it KR1. I'm going to specify that this keyring is for VRF red. That's my first change. So I'm going to be setting the key, not using the global parameter. I'm going to create a special keyring that will hold the key, the pre-shared key for the destination address. Good. So I'll say pre-shared key based on address. The key is Cisco 123. Address is 10.12.12.2. Which VRF E01 belongs to? E01 is this interface that belongs to the red VRF. Got it? Let's just check the syntax real quick over here. We do this on R1. You can. The name of that VRF is default. So you would specify default over there. Oh, sorry. The newer ones, they have this. On this one, is just crypto keyring KR1, VRF red. I don't know what iOS has running. Certain ones don't support it. So that's why I wanted to check which one this one was. Address, I have it a couple of times. 10.12.12.2. Key is Cisco 1. So I had the address twice. So over here, it is just keyring. Later on, we'll also do a keyring for IKV2, which is going to be based on IKV2. We'll do that later on. So crypto keyring KR1, just a name, for which VRF? VRF red, and the key is for 12.12.2, which is the peer address over here. And the key is Cisco 123. Everybody okay with this? And you understand why am I doing it based on the keyring? Because by default, the crypto Aiesec key that you have is for the default VRF. Now, the next thing that I need to do is I need to attach this to my crypto map. Well, the keyring cannot be attached directly to the crypto map. What phase is this in? Where's the keyring? Where's this pre-shared key at? Phase 1 or phase 2? Phase 1. So what I need to do is I need to create what is known as an Aiesec profile, which will point the keyring, and I will attach that to the crypto map saying, hey, listen, use a keyring for your, what do you call it? For your authentication for pre-shared key. So to attach this keyring to my crypto map, what I need to do is I need to create a Aiesec profile, because this is for phase 1. I'll call it, I'll just call it Aiesec profile, Aiesec prof, Aiesec prof, right? in there, I'm going to specify the VRF that I'm using is red for what? For this profile called Aiesec. I'm going to specify my keyring that I'm using is KR1, and the identity address is 12.12.2, 255.255.255.255, and it will be found in the VRF called red. So basically what this does is the Aiesec profile, Aiesec says, hey, listen, whichever crypto map I apply Aiesec for, it will be referencing the VRF red. It's going to use a keyring KR1, which is this guy over here, and it matches the identity 10.12.12.2, 255.255.255, basically this particular address for VRF red. Now I can go ahead in my crypto map, I can specify crypto map, CMAP, Aiesec profile is Aiesec, because this profile, this crypto map is applied to an interface which is inside the VRF red. It knows where now to go and check for what? The key. So Aiesec will tell it, hey, listen, whenever you want to check the key for the peer 10.12.12.2, go and check it against the Aiesec. It'll tell you where. So Aiesec tells it, hey, this is for VRF red. Is it VRF red? Yes, it is. Is this the destination address in VRF red? Yes, it is. The keyring is KR1. KR1, again, you need to make sure it's for that particular VRF red. This is the address and this is the key. So these are the extras that are done over here. What are the extras? You need to do this part over here where you create a keyring. And then once you create a keyring, you apply the keyring inside an Aiesec profile, which in turn is applied to your crypto map. Do you see the differences? And the only reason is the key cannot be identified because by default it is for the global VRF, which is the global routing table. So the key we've done, let's just do the whole thing, copy paste it. Let's check, this one went okay. This is okay because it says, hey, it's already there. Created the VRF red, keyring KR1, match identity for 10.12.12.2, 255.255.255 for VRF red. Phase 2 went okay. My ACL is there. Everything is there. Now the good thing is, because I did it in Notepad, what do I do on the other device? Just the same thing. I will flip it. I can even follow the same. Point it to what? 12.1 because I'm pointing back. Again, in the match identity, I'm going to point it back to 12.1. Transform said ACL, I need to flip. Crypto map is all good except for the set tier, and I apply it. You guys understand this? So I can now copy this onto R2. Done. Now, first thing, I need interesting traffic, so the tunnel is down on R2 or on R1. Okay. Now, where do I need to go to initiate the traffic so that the tunnel comes up? Where do I need to start? I need to go to R3 and ping 10.4.4.4 with a source address of what? 10.333. In the routing table, it'll say it has been learned from R1. R1 receives it. It checks it. It says the outgoing packet for that is E01. As soon as it hits E01, what does it do with it? Oh, there's a crypto map. Is this interesting traffic? Yes, it is. It goes through the IPsec process and creates a tunnel between what? R1 and R2. Good so far, guys? You guys ready to test it? Any questions at this time? All right, let's give it a try. So I'll go to router 3, show IP route, EIGRP. I have 10.4 over there. My local interface over here is 10.3. That is my interesting traffic. So I'll say ping 10.4.4.4, source is 10.3.3.3. It works. Now, I don't know over here whether it's encrypted or not because I'm not doing any encryption over here, right? How do I know it's actually working, going through the tunnel, or is just going through normally? I need to go check on my IPsec device. Over here, if I do crypto Aiesec SA, what do you guys see over here? Oh, there is a tunnel over here, right? Show crypto IPsec SA. Now, over here is where it tells you that I am doing the encryption. See the 14 packets? And it tells you that this tunnel is for what VRF? VRF red. Okay? Now, if I go to router 3 and I do this ping, will it go through the tunnel, the IPsec tunnel? Think about it. If I just say ping 10.4.4.4, I'm sitting on router 3. What does the packet look like? It's going to the destination, because I'm typing in 10.4, is going to be this. The source is going to be this address. The outgoing interface. Agreed? When it hits router 1, it checks it against the crypto map, says it's not interesting. What does that mean? It's not interesting. Does that mean it drops a packet? No, it'll forward it. It won't just encrypt it, it'll just route it. Normal routing. Take a look. It still works, but if you keep an eye on the counter will still be at 14. Okay, I'll do it again. I'm sending the pings. It's not incrementing. All right, but if I go over here and source it, now check it, the number has increased. So what's the main thing that you learned over here in terms of doing IPsec with a VRF in question, a protected VRF as they call it? The difference in the configuration is just this part. And then you also apply it to your Aiesec profile. Good, everybody? Segregation of the traffic is done based on VRF, and then the encryption is done based on IPsec. All right. Somebody asked me a question earlier yesterday about FVRF and IVRF. Do you guys remember that? Can you have normal IPsec along with VRF? Yeah, absolutely. For the global routing table, you could still do the normal VRF. I don't have any other interfaces left because I had 4 interfaces on the router, or on all 4 of them have been allocated right now. Now with what is the forward VRF and the internal VRF? There's FVRF and there's an internal VRF if you want. Generally speaking, you just work with the IVRF, which is the one that we work over here with based on. But there are certain instances where you might have a forward VRF as well. You have a different forward facing VRF and you have an internal VRF which is different. This is done in in situations where you do not want your internal routing to be made available to the service provider. Let me explain that. Actually, I'll point you to videos. I don't want to take too much time over here. I have specific videos just for that on YouTube. Now they've changed the way it looks. Do you see these two videos that I have on YouTube? They're specifically for that. Front door VRF and MPLS with just DMVPN with the IVRF. Okay, take a look at these two videos. They're long videos. They go in detail about how and when would you want to use an FVRF. Just remember, generally this type of setup, the FVRF and IVRF is done in a MPLS type environment where you as the customer do not want to share your entire routing with the service provider. You want to hide it. So all you're going to do with this type of setup is you're going to have two different VRFs. I'll just explain it real quick. I don't want to get into details about it because it's a big topic, but I would recommend watching these videos, these two over here. So how do I get them? I'll just share the link over here. This is one of them. But it's a long topic. That's why it would take me a couple hours just for each one of them. I'll give you an overview of it so that you guys understand it at least. All right. These are the two videos that I have for them, but let me explain what they are all about. See, sometimes in some instances, let's say you're running an MPLS VPN network where your private networks are connected through the cloud. So this is your service provider cloud over here. This is your provider edge router. This is your core provider router, and there's another provider edge router. Let's put another one over here, another provider edge router, the PE router. Generally speaking, with MPLS, what happens is the provider edge router runs a routing protocol with the customer edge router. These three customers all belong to the same company. All right. So these are three different sites belong to the same company. Normally speaking, what happens with MPLS is this. You run a PECE routing protocol to exchange the route. With your provider edge. So let's say these are three sites over here. Site 1, 10.1.1.0. And let's say 10.1.2.0. Second site, 10.2.1.0. 10.2.2.0. 10.3.1.0. and 10.3.0.0. All right. Now, what happens is when you run a PC routing protocol with your service provider, you're actually letting the service provider know what your routes are. So he will propagate those routes to whom? To the other PE sites. And the PE sites will send it to the other sites belong to the same customer. So you would get your routing exchange with your provider, and the provider then in turn will send it to your site routers. Everybody okay with that? But what you've done is you have exposed your internal topology, internal routes to whom? To the service provider. You get my point? Now, in some cases, you don't want to do that. So what you do is you put this interface in a separate VRF. Its job is just to learn the routes of how to reach what? CE1, CE2, and CE3. So in the forward VRF, the front door VRF, the front door VRF would contain routes. Let's say this network over here is 192.1.10.0. This is 20.0. These can be private addresses because MPLS can be on a private segment. This is 30.0. Is it? Maybe. Sorry about that. Maybe that's what it is. Okay. All right. So you see the green over here? So in this front door VRF that I have is going to be just the routes for what? Reaching the other customer edge routers that I have. Okay. My other interfaces, my internal interfaces are over here. This allows me the ability now to set up a VPN, maybe a DMVPN. Generally, this is the preferred one over here, to run routing from the CE router to the other CE routers. Reachability from the CE router to the CE router is done through the front door VRF. Whereas the actual routes that are getting propagated through the DMVPN is in a separate VRF called the internal VRF. The tunnel interface itself will be in the tunnel that you create, the DMVPN tunnel that you create will be in the internal VRF. The front door VRF is just used for what? Reachability to the other tunnel endpoints. That's where you use a front door VRF, the FVRF. And that is just used for reachability to the other PE routers. Not just adjacency to the PE. Through the PE, I also need to know the address for what? CE1. Because my DMVPN will be set up from where? CE1 to CE to CE3. Maybe this is my next hop server. So I need to know how to reach the next hop server. That will be done through the front door VRF. But in the front door VRF, the FVRF that I have in the front will have no idea about what? 10.2, 10.1, 10.3 routes. So the only purpose of the FVRF is to do what? To provide reachability for those different edge sites. Understood, guys? And then you have the internal VRF to do your routing. Now your routing is done directly from what? C to C. And the reason I'm saying DMVPN is a better way of doing it because it's scalable. You get my point? You at least have an idea what FVRF and IVRF are. Got it? And this is the situation that you would use a front door VRF to hide your route from your service provider. Again, take a look at the two videos. It has them. One without the front door VRF, one with the front door VRF. So the two VRFs must talk to each other on the CE routers. They don't talk to each other again. What they do is they use the, when you create the tunnel interface, you have two VRs. The front door VRF is just for the reachability. For example, in the tunnel interface tunnel, let's say X, you would still put this tunnel, as I said, in what VRF? Internal VR, right? So your VRF forwarding command would still be pointing to what? The internal or the IVRF. Okay, but then over here you would specify your the tunnel reachability, so that when I go and say IP NHRP, for example, NHS is 192.168, let's say 1.1, and I say IP NHRP map 192.1.168 1.1 is reachable via 10.1. Now, how do I reach this? That is the tunnel forwarding VRF that you will have. So that's where you will point to the front door VRF. So you will have this interface in a different VRF. The physical interface will be a different VRF. So the front door VRF has to be established first. Absolutely, that would provide the reachability. So the CE routers are reachable to each other. So they're not talking to each other. So don't think that your routes are going from one VRF to the other. The internal VRF is talking directly to the internal VRF on the other CE router. The front door VRF is providing what? The reachability to the destination. Does that make sense, guys? So I'm not exchanging the routes between IVRF and the FVRF. They're used for different things. Good? Provides a transport for the internal VRF. That's a better way of doing it, yes. So rather than saying they must talk to each other, front door VRF provides the reachability for the IVRF. All right, and that's something that if you look at these two videos, you will see I shut it off now, but the links that I gave you guys, everybody have those two links? Take them down. If not, do a search on YouTube for my channel and it's there. That would basically explain the entire thing about FVRF and IVR. The thing about that is these things generally are not tested on any other CCIE exam, so you won't probably see it in most of the study material of any of the CCIE vendors, but it's something that I found was very useful for me when I was implementing it for one of my clients, and that's why I created the videos for it. These are old, not old videos, but they've been there for a while now. Let me just check. Yeah, both of them are about 2 years old. Yep. So it's not a new technology. It's just something that is not used as often. Not at this time, Alan. They haven't tested it yet, but something that they are putting in a lot of their blueprints. They will eventually test it, but not at this point. All right. Good so far, guys? All right. While we're at it, there's the annual package thing. Let me explain the annual package, and then we'll come back and do this other thing as well. The other things that are left over. So we're at this point right now. This doesn't take that long now. This one is a big topic. It's not a small topic, but I'll introduce this topic to you guys. We'll do this. We'll go into Flex VPN, but before that, let me go ahead and open up a document for my annual package. This is the latest one. Yep. Now, a little bit of marketing. I have an annual package that I teach these CCIE classes. I teach route switch, service provider, security, data center, and CCDE. The classes are taught on the weekend. All of the classes are on the weekend. I generally have 3 slots. There's a slot on Saturday for 6 hours. There's another slot for 6 hours on Sundays. And there's a slot which is in the evenings. Evenings for me, which is mornings for you guys. So every weekend I'll do 3 courses. I'm doing 3 courses at this time. What are the different tracks that I run? Route switch, service provider, security, data center, and CCDE. It's an annual package in which you can take as many classes as you want that I offer for an entire year. The cost of the entire package is $3,000. So essentially, even if you take the class once, it comes down to, let's say, $600 a class. You have unlimited classes that you can take. You can sit in multiple classes. Workbooks are included. And in some cases, I do have rack time as well. See, for example, these are the different, forget about from the perspective of the certification. The thing that I like about the classes, and that's what the feedback that I've gotten from the people that have taken it, is the amount of information that you get in terms of learning. The technologies that you get good at are that make you a well-rounded network engineer, security engineer for that matter. Routing protocols, we take a look at RIP version 2, RIP-NG, EIGRP, both for IPv4, IPv6, OSPF, OSPF-v3, BGP. Now, these protocols are taught in generally the route switch, as well as the, actually I should also add ISIS over here, because I do teach ISIS in the service provider, so you also learn that. Switching technologies, rapid PBST, MST, VLAN ACL, SPAN, VTP, a bunch of different switching, because if you take a look at your switching from the perspective of the Nexus, you learn a lot of switching on the Nexus switches over here. Because in the data center class, basically it's those 9K, 7K, 5K, 2K switches that we do extensive switching on, besides doing it on the Catalyst for your route switch. So route switch as well as for DC that you learn this. Multicast routing, both all PIM, dense mode, sparse mode, MSDP. This is again in route switch as well as service provider. In the service provider, we also run a multicast MPLS VPN. So within an MPLS VPN, we also run multicasting. Quality service, policing, shaping, CBWFQ, LLQ. We do MPLS QS as well. I don't have the entire thing listed over here. That's part of the service provider class. So RS as well as SP. Security technologies, ASA 9.x, VPNs. What we covered over here a little bit more into things like Flex VPN. ACS, actually, I'll take that out. I don't do that anymore because it's now end of life. Instead of doing what we used to do on the ACS, we do it on ICE. Okay. The device administration that used to happen on the ACS, it's an end of life device now. So we do it on ICE. We take a look at FTD, ESA, WSA, wireless security. We set up the WLC with the AP. Again, ACS is gone. I don't know why I have it twice. I'll take that out. This is all on the security class. MPLS unicast routing, MPLS VPNs, intra-AS, inter-AS, MPLS multicast that I talked about, MPLS TE, MPLS Atom. I'm also adding segment routing over here. CSC as well, absolutely. Is the format similar to this or what? As I said, the classes go on Saturday and Sundays. But the way I teach is exactly the same. It's generally a 4 to 6 hour class, either on a Saturday or a Sunday. If it's a 4-hour class, it's both on Saturday and Sunday. Same basic format. Now, one of the things that happens is because it's a smaller class, it's not like 80, 60 people. What I do for the class is, let's say you sign up for the thing, I record every class. Like I'm recording the class right now. I record the class, my notes that I have been making, the notes and the diagrams. At the end of the class, what happens is it takes about, for Zoom, it takes about an hour to render the video file. After an hour or maybe a couple hours, if it's too late, I'll do it the next morning. I'll send you a link to download all that. So let's say you miss a class, the next morning, you will get a recording of the class. Let me show you the way I've organized it so you guys get a chance, you see how it's done. So for example, I'm doing a security class over here. So at the end of the class, there's a recording for it. And then in my annual package for the same class, same date class over here, what I do is there's an email list. So I keep everybody's email over here. At the end of the class, I blast an email with the link to download it. And these are the video, the diagrams, just the way I've been doing in the class over here. And along with that, the notes. So every class, every day, I have the notes that go along with these type of things. It's the number, rather than the days, I would tell you the number of hours. Generally, any of these classes that you have run from 50 to 60 hours. Any of them. So pick a class, like out of the 5 classes, all of them are 50 to 60 hours. And the good thing is it's on the weekend. So you get the entire week to yourself to study. If you have to study it, you want to do the labs, you have the ability to do the labs on your own. And the next time you come in, we start with the questions for what you had done the last time around and take it to the next level. Once you sign up, I'll send you an email. I have an email list of all the people that are on the annual package. I send an email to them that this is the class starting, something similar to this. For example, let me show you this. This is like the template that I have, the timing of the class. See, normal class, I would charge $2,000 for a single class. So I have a discount fee for the one that I'm starting tomorrow. It's $1,500 and with the link on it. So you can join it. So you get an email based on that once you sign up for that. Besides that, I'm setting up my a website, which should be up in about a week. That will also have the schedules, which is my website, khawarbutt.com. So you will also see schedules over there for the classes. So on a regular basis, I'll have that. So every weekend, you'll have 3 classes. Now, the way it works is, for example, right now, I'm doing starting CCIE security tomorrow, which is slot 1. Slot 2, I've started already, which is CCIE SP, CCDE, followed by CCDE. They go hand in hand. And slot 3, I have CCIE route switch. Slots, in terms of the timings of the slots, you can see that on that annual package list that I gave you. So there's 3 slots every weekend. Now, as soon as this slot frees up, I will run another class over here. I won't repeat the same class in that slot. So for example, security finishes up. I'm probably going to be doing CCIE data center in that slot. If this finishes over here, I'll do route switch in that slot. If this finishes over here, I'll probably do security in that slot. Okay. SP Mo is almost done. I'm actually on the last topic. I have to do MPLS QoS tomorrow, and then we go into CCDE on that. But then what happens is, as soon as one of these classes finishes, over here, the next iteration would be SP. So I rotate the classes so all the different slots get a hit of different classes. So if maybe one time is not suitable for you, you take the class that is in the suitable time, and then you move forward to the other slot. Yeah, I do have Skype, but better you send me an email. I rarely check my Skype. Can you provide more details on the lab rack? Now, the tracks that I do, route switch, it's all based on IOU. If you want, you can do EVNG. So the entire rack for route switch, even when you go and take the exam at Cisco, it is a virtualized environment. So you don't need a rack for a route switch. Service provider, exactly the same thing. I would do it, I generally do it on IOU and EVNG. The entire track can be run over there. Okay, so that's 2. CCDE, again, does not require a rack. It's all based on scenarios and design. Then you have security. 80% of the track can be run on EVNG. 20% you need physical equipment for. As part of the annual package, I give you 50 hours on the physical rack, my physical rack. The only one that I do not provide is data center. Data center, the data center rack is not included. So that's the only one that you would actually need to do what? Rent the rack. Does that answer your question, Raza? Email address. Or you can also send me an email at gmail.com. When do you sleep? During the day, man. No, these classes are on the weekend, so weekend is hectic for me. But then during the weekdays, I try to space it out. Any other questions about the annual package? The other thing is I'm doing a boot camp. Let's say you want to do a boot camp as well. There's a boot camp which I'm running with Micronics, which is starting on the 9th of July. All right. It's at a discounted rate again. It's $1,800. Now, if you want, you can pay the $1,800 into the Micronics class. And then if you want to jump on and you just need to pay $1,200 extra to go into the annual package. So you have the ability to take that class on the 9th of July and pay me another $1,200 if you take that July 9th class. It's a Monday through Friday class, through Micronics. You can contact Micronics for that, and you can sign up. Or you let me know if you want to join that class. I'll send me an email, and then I'll guide you how to sign up for that class. That's also that's coming up. That's in about a couple of weeks, 3 weeks from now. Sales@micronics.com. There you go. Or JanetK@micronicstraining.com. So even if you sign up for that discounted rate, I will give you credit towards your annual package. Yes, I will also do the September bootcamp. But I think you need to sign up within the next, I don't know, couple of weeks to get that $1,800 discount. Check with Janet about that. No, for my work, for my bootcamp, I provide my own workbook. Where's the bootcamp? I think it's online, but if you want, you can. The one in July 9th is CCIE security. Route switch, the Micronics one, you do it through Narvik. My route switch bootcamp will be part of the annual package. The boot camps that I do, like a Monday through Friday type of thing, I only do it for Micronics. I generally don't do it as part of my annual package. I just do the annual package on the weekends. Ninth, I think it's online, but if they have enough people, I can fly there. That's not a problem. I'll talk to, if you are interested only on an on-site type of thing, we can do it over there. I can do it in LA. And then for the people that cannot make it, I'll also be an online. So it's an on-site, online combined can be. That's not an issue. Good. Any other questions regarding the annual package? If you need the information, like the document and all that, I've given you my email addresses. I'll just put it over here as well at the top. Send me an email, and I will send you the information about it. And that's the marketing part of it. Now, going back, let me just create this first. The next things that we need to finish off on over here are these three things. This is a good time to take a break. We'll come back after the break and we'll take a look at these. Otherwise, it'll be too long of a lecture. So when we come back after 15 minutes, we'll take a look at these things. So it is 10:35 right now. Let's take it to 10:50, 15 minutes. We come back, we take a look at IKE v2, legacy-based, SVTI-based, and then we'll also rope and flex VPN over there. What's the difference between the Micronics and your weekend package? Micronics is a boot camp, which is a 5-day boot camp, Monday through Friday type of thing. Everything will be covered in one shot. Whereas my classes are like a long, it's spread over 8, 9 weeks. Good. As I said, shoot me an email and I'll send you the information about the annual package. Let's take a break. We'll come back and we'll start with IKV2 and FlexVPN. Hey guys, everybody back? Ready for Ike version 2. All right. Let me bring the topology up. Which one should I do? I'll shut these routers off. Yeah, this is good enough. Is there sound? It should be my sound. I was getting some sound, so I just made sure everybody's muted. Can you guys hear me, right? Yeah, that's important. Okay, so let's create this diagram over here. I'm going to use this. Okay. So this is my network over here. Let me just put some IP addresses on the diagram. Explain the topology to you. (192.1.20.0). This is 10.0. 50.0. 30.0, and this is going to be 40.0. Now this guy over here in the middle is your service provider or the internet. So think about this being your internet. These being different public connections towards the internet, different locations. All right. This is my diagram. Now let's go and understand what IPv2 is. Oh, okay. And you can't hear anything, huh? Yep, it has happened to me. Okay, now the first thing that you guys need to understand over here is whatever I talk about right now in terms of your IPsec, it only deals with phase 1. Phase 2 does not change. So whatever we're doing over here is just a variation or an upgrade to Aiesec. Aiesec also had another name called IKE, Internet Key Exchange. Initially, it was just Aiesec and IKE. They wanted to improve phase 1. So they came up with a second version of Ike called Ike version 2. When they came up with Ike version 2, this automatically became Ike version 1. But initially, it was not called Ike version 1. It was just called Ike or Aiesec. Basically the same thing. Two different names for the same technology, UDP 500. Even this one doesn't change. It's still UDP 500. But the way things are done over here is different. So I don't want you guys to overthink it. Just remember, whatever we're going to do is going to be changing what? This part here only. This one and beyond remains the same. Okay? Clear on that? Yeah? Hello, hello, everybody there? Okay, good. Just want to make sure that you guys are dialed in. So there you go. I love that. Now, in terms of the changes that you see in Ike v2, let me explain them to you guys. In terms of, from a configuration perspective, changes that affect you. There's things that they've done underneath the hood, basically in terms of making it more efficient. That's something in terms of the package that they've taken care of. But in terms of you implementing it, what are the different changes that you would see or you would feel? Let's take it one step at a time. The first change that to me is a nice change, especially from the perspective of scalability, is let's say you had a router and it needed to set up different VPNs with different companies, maybe extranets, but they all wanted to have IPsec. This is company A, company B, company C, and company D. These are clients of my company, my enterprise, and they want to set up an IPsec to exchange some traffic. But they're the ones that are dictating the policies for phase one. What do I mean by dictating it? For example, A says, you know what, I want to do authentication as pre-shared. I want group to be, let's say 2. My encryption should be triple des, and my hash should be MD5. Done? This guy over here, second company says, I want authentication to be pre-shared. My group should be 2. My encryption should be AES. My hash should be MD5. The third guy over here says, I want pre-shared key, I want group 5, I want AES, and I want SHA. The last guy says, I want pre-shared, I want 5, I want AES, and I want PSK5 AES and SHA. These two are the same. So how many different policies do I have over here? This one, completely different than this one. These two are the same, but they're different from the other one, right? Now, all of them need to be created where? On the central router that needs to establish phase one with all 3 of them. What do I need to do over here on router 1? I need to say crypto, Aiesec policy what? 10. A crypto map later, but let's do the policies first. And I would need to have the policy that matches 1. And I would have a crypto Aiesec policy 20, which matches this guy. No, not flex right now. This is just Ike v2. So I would create 3 over here, right? That's the first difference that you have in Ike version 2. The way you configure this, rather than creating 3 different policies, they introduce a newer component. The new component in Ike v2 is called a proposal. In this proposal, I have 3 parameters. I have my encryption. I have my hash, which is called the integrity. And I have my group. The auth pre-share key or PKI is done differently at a different place, but in my prop, I have these 3 parameters. In the proposal, though, I have the ability to specify that I want to use encryption as triple DES or AES, which would take care of all the different encryptions that I have, doesn't it? I either have AES or triple DES. When I say triple DES or AES, it takes care of it. Integrity, I'll specify my integrity is either as MD5 or SHA. And the group I either have as 2 or 5. What the proposal will do automatically, it will create all the different combinations that I can get from these different parameters. So it would automatically create the policies for me, which have all the different combinations. So automatically it would send to the clients a policy of what? Triple DES, MD5, 2. It would send triple DES, MD5, 5. It would send triple DES, SHA, 2. It would send triple DES, SHA, 5. It would create all the combinations. AES, MD5, 2, AES, MD5, 5, AES, SHA, 2, AES, SHA, 5. Not only would it have the 4 that I need, it would create all the different combinations that are possible from here. Basically, in the proposal, I have specified which ones will I support. It automatically will create all the different combinations. Understood? So first change that you guys see over here is the concept of what? This proposal. In the proposal, the advantage that you gain is what? The ability to expand or scale to different combinations automatically. Again, it is not Flex. This has nothing to do with Flex. This is Ike version 2. I'll explain Flex later on. This is not Flex. This is Ike version 2. Negotiate I could do with the Aiesec policy as well, Sinad, but I would need to create those policies myself, individually. If I had to do this, I would have to have 8 policies. Crypto Aiesec policy 10, 20, 30, 40, 50, 60, 70, 80. I would need to create it as the administrator. Here, I don't. I just say encryption triple DES AES, integrity MD5 SHA, group 2 and 5. It automatically will do what? Expand and create all of them. So you as the network administrator don't have to do that. You guys clear on this? Okay, good. So that's the first change. The introduction of the proposal component, which allows you to dynamically create multiple policies on the fly. All right. That's number one. Number two change. When we are talking about pre-shared key, what was the pre-shared key used for? Again, for phase one, right? As I said, IP1 is only for phase one. It's not backward compatible. You need IP1 will only talk with IP1, IP2 will only talk with IP2. The router can have both, but it needs to run IP1 with the appropriate device, IP2 with the appropriate device. So it's not like I'm going to create IP2 policies only and have it work with IP1. Now the other difference over here. Remember the pre-shared key that I created? Let's say I create pre-shared key Cisco. And I have a pre-shared key over here called Cisco. Agreed? So it's the same key that needed to match, right? Fine. When I'm sending information in this direction, what key am I using? Cisco 123? Right? And when I'm sending information in this direction, what key am I using? Same key, common key, right? That's IP1. In IP2, you do have the ability, if you want, you can do the same thing. You can create a common key. But in IP2, you do have the ability to do this if you want to. It's an option. What you can do is you can say when A sends data or encrypts data towards B, I want the key to be 111. So the encryption key over here is what? 111. What would he use for decrypting? He needs to use the same key for what? Decrypting. So the decryption key over here is Cisco 111. But unlike IP1, where you had the same key on both sides, I do have an option of specifying a different encryption key over here. Cisco 222 to encrypt. So he will decrypt over here using what? 222. Understood. So now you have the ability to create what? Separate keys for encrypting A to B and a separate key from B to A. By the way, guys, this thing, creating a separate key from A to B and a separate key from B to A, is the default behavior of what? Phase 2. Remember the session key part? In phase 2, session key, there's a session key from where? A towards B. Let's call it session key 1. This is the encrypting key over here. Session key 1 over here is the decrypting key. I'll use session key 2 to encrypt, and he will use session key 2 to decrypt. This is the default behavior of what? Phase 2 anyways. But in phase 1, IP1 used to work with a common key, common pre-shared key. But now you have the ability to put them as two different keys. So what's the difference? How does it matter? The way it matters is if I use the same common key and I was sending total of, let's say, 1,000 bytes. Now the 1,000 bytes were encrypted and decrypted using the same common key, right? Now, because it's halfway, only 500 bytes are encrypted using Cisco 111. The other half, which is the return traffic, is encrypted using what? Cisco 222. So half of it, right? You guys remember what I told you? To crack a key, what do I need to have? A lot of data, right? So it reduces the probability of an attack. Absolutely. So if you want, you can take advantage of that. There's not a lot of data in phase one, but even with that, you're reducing the likelihood of an attack. Good so far, guys? You understand that? Now, similarly, do you remember you could do, you have two ways of doing authentication in the first phase. What are the two different ways? We've only done one in this class, but I mentioned another one. One was what? The pre-shared key. What was the other one? PKI or certificates, right? In IKV1, I would need to either select PSK or PKI. So whatever I selected, it was a two-way thing. I would do a pre-shared key A to B, pre-shared key B to A. In IKE version 2, if you want, you do have the ability to say A to B using PSK, B to A using PKI. So you do have the ability to use pre-shared key one way, PKI the other way. Capability is there. Understood? Good so far, guys? Everybody understand this? So do you guys see the advantages that IKV2 brings to the table? All right. Now, let's see how to configure this. The configuration part of it. Let's do a crypto map configuration, which I call the legacy based. So IKV2 legacy based is your crypto maps. Okay. I'm doing it between R1 and R2. How would I do? What are the steps that I need to do for just the overall steps? If I wanted to do a crypto map, IPsec LAN to LAN between router 1 and router 2, what's the first step? Phase 1, good. What's the second step? Okay. Third step. Brilliant. Step 4. Key would be phase 1 as part of phase 1, Aiesec. Step 4. Crypto map. And step 5. Agreed? Aren't these the 5 steps that I have? What did I just tell you? These remain unaffected. When I do IKV2, what's the only thing that I'm changing? I'm changing Aiesec. Good so far? Okay, what are the changes for phase one? Let's take a look. It is a little bit more involved. So phase one now is broken down. I break it down into 4 sub-steps. Step 1, configure the proposal. Remember, before we did not have that proposal concept. Why not? Because I would create multiple Aiesec policies. Now what I can do is say crypto IP2 proposal, give it a name, whatever you want to call it, prop1, just a name. Here I'm going to say my encryption is triple des, and I just choose triple des as encryption. Hash, I want to use MD5 or SHA. SHA, I think, has one. SHA-1, there's, and the other thing that I'll also show you, it's got a lot more secure mechanisms in place. I'll show you that as well. Actually, let me do this with the question mark. It makes a little bit more sense, and we'll come back and put it over here. So I'll go to router 1. My topology is this. My objective right now, my first objective is to set up a IP2 with what? With let's do crypto map. Sorry, that's my objective. So I'll go to router 1, crypto Ike v2 proposal prop-1, just a name, any name. Now I need 3 parameters over there. What are the 3 parameters? Group, encryption, and integrity, which is hash. So let's start with the integrity, which is your hash. What options do I have? I not only have MD5, I have SHA-1, which is the SHA that we have been talking about with IP1. We also have SHA-256, SHA-384, SHA-512, which are more advanced, more secure hashing algorithms. So not only can I do this, but I also have the ability to use more sophisticated algorithms, making it more secure. When I say integrity, MD5, and SHA, what does that mean? Either MD5 or SHA in conjunction with the other parameters. Understood? That's why I wanted to do it in your config, because I wanted you guys to see the additional options that you have. Clear so far? Encryption. You have triple des, you have des, then you have different flavors of what? AES. Higher you go, more sophisticated encryption. What do I mean by more sophisticated encryption? It takes more time, but it is more secure. These are the ones that it supports. And as newer versions of the iOS come in, you will have more that will be added. But for right now, this is generally the one, these are the ones that are supported. So over here, let's do triple des, and let's do AES 128. Good so far? And the third parameter was what? Group. Again, take a look at the key generation techniques, a whole bunch of more than what we have. We'll say 2 and 5. So if you take a look at your crypto now, in my proposal, what have I mentioned? Encryption as triple des as an AES 128. Integrity as MD5 and SHA-1. Group as 2 and 5. That would create for me 2 to the power of 3, which is what? 8 different what? Aiesec policies. If I had to do the same thing with Aiesec, I would need to manually create 8 policies, which I've already defined over here. because this will expand into the 8 policies. Everybody understand that? That's the example that I went through. I'm just showing you the command to do that. Yeah? Next, although the proposal will create the policies, it's not going to be called. I need to call it. So this is my step B. It still calls the policy. So configure the policy, attach the proposal to it. So my crypto map will still call the policy. So I still need to create a policy. It'll be an I-create2 policy, whatever you want to call it, call one. The main thing, the only thing that I need to specify over here is, hey, proposal is prop1. So I'm linking the proposal to where? To the policy. Because the policy is the one that will be called. Everybody okay with this? So how many policies have I created? I've created 8 different policies at this point. Step C. Because the pre-shared key has a lot more capabilities for me, I cannot do a normal key. The way I need to do the key, even if it's a common key, it's done inside a keyring. Configure an Ike v2 keyring. I need to paste this. I pasted one, so I'm going to paste it as we go along. It says Ike v2 policy must have at least one complete proposal attached, and that's what I'm attaching, proposal prop 1. That will attach all the different combinations over here. Good. The next thing is configure an Ike v2 keyring. Crypto Ike v2 keyring. Let's call it KR1 or KR12, 1 to 2. Here, I'll define my peer. I'll say peer R2. That's just a name. This is insignificant. You can call it ABC if you want. But as soon as you say peer 2, R2, it puts you into subconfig mode. Okay. Under peer R2, now I'll define my address. All right. And over here, I'll define my pre-shared key. Wasn't that simpler? Crypto, Aiesec key, Cisco, address 123, whatever. Here I'm doing it inside a keyring, right? The reason they do it like this is because of that capability. If I wanted to do a common key, this is a common key mechanism. But do you remember what I told you that the pre-shared key can be? From router 1 to router 2, I can have a different key. From 2 to 1, I can have a different key. Right? So if I want to do that, where I want to use a separate key from A to B and different key from B to A, they needed to give me a capability of doing that. That is done inside a keyring. So the way you do that is rather than saying pre-shared key Cisco, you say pre-shared key local. That is my encryption key. Let's say Cisco 123 or Cisco 111. And then I'll say pre-shared key remote. In other words, this is my encryption key. Okay. This is what I'm going to use for decrypting, because the other guy will be encrypting using what? This key. What would I do on R2? Help me out. What would I do on R2 if I had done this on R1? Point the address. I would change this to remote and change this to local. You get my point? Because local is my encryption key, so whatever I encrypt, it'll be used over there. We'll do that on the other one later on. But do you guys understand this? I'm going to do this mechanism right now, not the common one. What if I wanted to do the common one? The address followed by just pre-shared key and the key. No local, no remote. Understood? Perfect. The fourth step. Configure an IKV2 profile. This profile will be attached to phase 2. This is the profile that will tell my device I want to do phase 2. Up until, if I don't do this profile, my crypto map doesn't know whether I want to do phase 1 or phase 2. So this profile, when attached to your crypto map, will tell crypto map do phase 2. And what does this profile contain? Crypto IKV2 profile, whatever you want to call it. I'll call it IKV2 prof, just a name. Match address, the match address, remote identity, match identity, remote address, I think. We'll check that. The remote address is 20.2. So basically this profile is for what? The remote address, 20.2. The authentication that I want to use, remember what I told you, you can do local as pre-share and remote as PSK if you want. But even if you're not, you need to specify that. Phase 1 is only active when setting phase 2 up, right? Correct. Phase 1 is called from phase 2. But once phase 2 is active, phase 1 will be in idle. That is correct. Yes. But how is phase 1 called? Where's phase 1 called from, Chris? Phase 1 gets initiated when interesting traffic hits on phase 2 or on the crypto map, which calls phase 1. You get my point? It gets called from the crypto map. Okay. And the last thing in this, you'll specify my keyring, locally created KR12. So I link because I said local pre-share, remote pre-share. Then because I'm doing pre-shared key, where is the pre-shared key coming from? KR12, this guy over here. So that's how you link up your keyring over here. True, you're absolutely right. There's not a lot of traffic going on it, but let's say you want to make it a little bit more secure, making it last a little longer rather than keep changing your phase 1 pre-shared key on maybe a monthly basis. Now you can last for another 2 months because you have half the traffic going through it. It's another additional capability that you do for people that are more security oriented. All right, so these are the 4 steps that you need to do to connect phase or configure phase 1. Configure the proposal, policy, the keyring. Did I create the keyring or no? I need to take this off then. Otherwise it's gonna honk off on me. And then the IKE profile. Copy it. Done. So the syntax was right. It Click the command, and I'm good to go. So show run, section crypto. This is now, ooh, very good. There's a trailing white space in the above pre-shared key. What's a trailing white space? This did not happen before. It's basically telling you have Cisco 111 dash. So brilliant. I did not know that it actually tells you that. You would do what I just did, like you would go like this to figure out if there was a space. See, there's an extra bunch of space in secure CRT. This one has it, but I didn't know that it actually in your running config would tell you that. This is a really nice feature. So now it doesn't have that message because my pre-shared key is good. Nice, saved us a lot of troubleshooting. That's phase one. Remember that phase one that we did? A little bit more to do. Again, gives you a lot more scalability if you had a lot of tunnels to create. I've created 8 policies over here. So if from a scalability perspective, it gives you a lot more. Now, how about phase two? How do I do phase two? Crypto IPsec, transform set, key set. You guys remember these steps? ACL. I have 10.1 going to 10.2. Crypto map. Now, in the crypto map, notice I just said IPsec Aiesec, right? Match address 101, set peer, set transform set. Now, where do you think it actually moves over to IKV2? It doesn't, did it? How does it know to do IKV2 over here? It's a normal commands, right? The way you need to link it up to tell it, hey, listen, don't do IKV1. I want you to do IKV2 is set the IKV2 profile. IKV2 prof is what I called it, this guy. So once I link it to IKV2 prof, it automatically does what for me? It initiates the IKV2 process versus IKV1 process. Understood? So that's what I was saying. This step over here is the link. This profile is the link that tells my crypto map, hey, listen, don't do IKV1, do IKV2. Because if I did not put this in, the default is what? IKV1. Everybody okay with this? So let's just copy this part over here. Done? So that's R1. Should be able to ping 20.2 just to make sure, yeah. What do I do on R2? Help me out with this, guys. Phase 1, I need to match. IKV2 is good. This one, I'm going to change to here as R1. That really doesn't matter. This needs to change. And what used to be a local becomes a remote. What used to be remote becomes local. Again, my address over here. Keyring, I called it the same. My transform set's the same. ACL. crypto map, and apply. Let's go to router 2. Paste it. If you take a look at R2, you'll see that 10.2.2 is over there. Let's put 10.2.2 on your diagram and 10.1.1. So I want to encrypt from where? 10.1 to 10.2. And I'm using IKV2. Same crypto map, but now I'm using what? IKV2. Everybody okay with these 4 steps, guys? Except for these 4 steps, it's the same. And understand what each one of those 4 steps does. Creating the proposal, following the proposal inside the policy, creating the keyring. Why do I need to create the keyring? Because of this local and remote type of thing. Following the keyring inside your IKV2 profile, specifying that I'm doing local as well as remote pre-share, and matching the identity as what? The remote address. Normal phase 2, normal ACL, crypto map. Link it up to IKV2 profile and apply it. I pasted it, yeah. Now let's test it. Ping 10.1.1.1, 10.2.2.2. Working fine. Show crypto Aiesec SA. Aiesec SA is for phase, IKV1. I haven't done IKV1. So what's the command for IKV2? IKV2 SA. The ready mean is good. I've used pre-shared key. This is my triple des, my hash, my group, everything is over there. Okay. The second phase is basically the same. There's no different. It's still based on UDP 500, four packets encrypted, 4 decrypted. If I do this again, goes to 9. So I'm doing IKV2. Understood? This is Ike version 2. Now, a lot of people refer to it as Flex as well when I was talking about it. I just want to make sure you guys understand what Ike version 2 does and where Flex comes into the picture. Ike v2 can be used in conjunction with IPsec LAN to LAN. Ike v2 can come in conjunction with DMVPN. Remember how we did DMVPN with crypto Aiesec key and the policies? I can use Ike v2 over there. I can use it with EasyVPN, the old remote access VPN. We haven't covered it anymore. It's not covered anymore, but it's there. SVTI, all of them could use Ike v2. Get VPN, for that matter, could use what? Ike v2. But this is not, except for SVTI, this is not Flex VPN. This is just normal VPNs, the ones that we know about, but using what? Ike v2 as phase 1. Understood? Everybody okay with that? Now the difference, the reason sometimes people get confused with Ike v2 versus Flex VPN is Flex VPN is a technology that allows you the ability that you would get with something like this, site to site, using tunnel mode as IPsec IPv4, using it in conjunction with MGRE, using it in conjunction with MGRE, basically with DMVPN, NHRP, all those different protocols, using it in conjunction with any Connect clients. So that's what FlexVPN brings to the table. So rather than having a different VPN for what? LAN to LAN, different VPN for DMVPN, different VPN for remote access, EasyVPN, I can accomplish everything under one umbrella, one command set. Although when you type it in, it becomes a little, looks like a little, it is a little complicated to configure if you do all of them together. But the capability of Flex is to allow a point-to-point VPN, a multi-point VPN, or a remote access VPN where a remote client connects in, all under the same umbrella. Hence the word Flex. So it gives you a lot of different capabilities. So it can do different type of VPNs under the same umbrella, same type of command set. Suite of setups that you can do under one umbrella. The confusion comes in. Any of the any of the Flex VPN configurations that you'll see, it will start with IKE v2. So IKE v2 is a prerequisite or a requirement for what? Flex VPN. So Flex VPN requires you to have IKE v2. But I can do IKE v2 with whom? DMVPN, which is not Flex VPN. I can do IKE v2 with GetVPN, which is not Flex VPN. Do you get my point? I have the same type of capabilities over here where in Flex with what? MGRE, DMVPN, NHRP, but it is not DMVPN. The configuration set is called Flex. Following or not? So with Flex, I can get the same spoke communication that I do get with what? DMVPN. I can get the same end result, but the command set will not be DMVPN command set. It'll be Flex VPN, which is a little bit more complicated than going based on DMVPN, which is easier to set up. But Flex gives you a lot more capabilities. Not only that, if I just want to do a normal tunnel mode IPsec IPv4, I can do that over here. All right. I can do any connect, remote access under the same umbrella. Over here in the older days, I would need to do what? Different type of VPNs, different command sets to accomplish either one of them. Good example, yeah. Before, when you did that, to take your point one step further, in the older days, there were different command sets for doing LLQ. There was a priority command set for that. Okay, fair queuing was done differently. The command set was different. There was a queuing mechanism called custom queuing. The command set was different. This is prior to the MQC. But then with MQC, what it gave you the capability of doing, the command set was different, accomplishment was the same. Got it, Kenny? Do you work with priority queuing or custom queuing prior to MQC or no? Yeah, before you had MQC, there were other queuing techniques which you could implement on the interface. One was called priority queuing. The other one was called custom queuing. You had fair queuing, all of them. Or for that matter, your policing used to be called rate limiting. Absolutely, yeah. It was not very good, but you had the capability of doing them as individual technologies. But then when MQC came about, you could do everything under the same umbrella. Similar to that over here. A lot more sophisticated because you have a lot more configuration under VPNs then versus doing it for QoS. QoS is not that, what do you call it? In terms of commands, it's not that many commands. Once MQC came out, they use that for everything. I don't even call it MQC anymore because a better name for it is Modular Policy Framework, MPF, the security name for it. The reason is it is more of a policy framework that you can apply for everything, whether it's quality of service, whether it's your security stuff, your policies and security, everything can be applied. So a more generic term for it is MPF. But initially it used to be called MQC because that's the only thing that it came out for. And that's true. They saw the benefit of MQC and they basically said, why don't we do the same thing with everything else? And they did. Understood, guys? Understand the difference between IKV2 versus FlexVPN? So IKV2 would be a prerequisite for FlexVPN. I don't know if I had a video on that as well on YouTube. Oh yeah. Old video, 4 years ago. If you want, what I'll do is, along with this video, I'll also include the newer FlexVPN video that I have from a recent class. Very true, Kenny. That's absolutely true. So when you're looking at hardware IOSs, IKV2 does not necessarily mean it's Flex. IKV2 could be DMVPN. IKV2 could be GetVPN. But if I say Flex VPN, that it automatically means you need to have IKV2. Good point. Good. Imagine what you can do in a year. All right, guys. So let's do another one. Over here, we'll do the Flex VPN, we'll do SVTI, the point-to-point. And I will include this as part of it. Let me see which one I have. Yeah, this one. What day is this? Good, it'll get you a whole bunch. BRF aware, get VPN. This is a more complicated one. I would give you that video. The Bruno Mars of CCIE, I guess. Subscribe to that YouTube channel. No, I'm not kidding. I'm just kidding. Subscribe to the annual package. What is it? This is what I'm going to give you, as well as part of the thing. This one. So you will get in this BRF aware VPNs, a more complicated example than the one that we did. Get VPN redundancy, IKV2, Flex VPN site to site, as well as spoke to spoke. This is your similar to your what do you call it? Your DMVPN type. Yeah, it's there. So this is the video that I'm going to give you guys. I'm going to send it to Katie as part of this class. So let's do this over here. We'll do another one over here. That will be your SVTI, which is also part of your Flex VPN. So let's do this between 3 and 4. So this is flex. Okay. Between R3 and R4, how do I do it? And this time around, I'll show you that common key. Now, I want you guys to participate in this. Help me out doing the phase 1 parameters. See how much you remember. So this is flex, site to site, IP2 using SVTI. R3, help me out with that. Help me out with the steps. What are my steps now? It's SVTI, normal SVTI. What are the steps for my normal SVTI? Phase 1. Phase 2. SVTI. Help me out. Come on. I'm waiting for you guys. No? SVTI. Tunnel is number 4. There's one step before tunnel. Transform set is phase 2. It's called the Aiesec profile. That's the one that attaches the transform set to the profile. Number 4 is tunnel. And number 5 is routing protocol. Because I'm doing static virtual tunnel interface, which is your tunnel-based IPsec. Right? Now I'm doing flex. So phase 1, how many steps? 4 steps, right? A. What was the first step in IP2? Proposal, brilliant. Configure the proposal. Crypto IP2 proposal, whatever you want to call it, POP1, has 3 parameters. What are the 3 parameters? Encryption, integrity, and yes, no ID, no. It'll automatically create the policies. What was the second step? B. Brilliant. Policy and attach the proposal to it. Simple step, crypto IP2, policy, whatever you want to call it, attach the proposal to it. Step 3 or C. Key. Crypto configure the keyring. I'm going to use a common key because I showed you the local and remote in the previous example, so I'm going to use a different one over here. Let's call it KR34, 3 to 4. Here, I'm doing R3, so R4 is my peer. Pre-shared key, Cisco 123. Notice I did not put what? The remote and local. 40.4, which is R4. So when you just say pre-shared key Cisco 123, that means a common key. Versus the other example that I gave you guys over here. You remember this? I'm just showing you both ways of doing it. Good? What was the last step in phase 1? Configure what? IP2 profile. Crypto IP2 profile. IKV2, call it prof, match identity, remote address is 40.4, authentication, local is pre-share, this guy is pre-share, keyring, local is KR34, and I'm done. With what? Phase one. Let's make sure that this works properly. Copy it, get this out of the way on R3. Done? What about phase two? That's the normal stuff. Crypto IPsec, transform set, pset, ESP, triple DES, ESP, MD5, whatever you want to use. Crypto IPsec profile, iprof, set, transform dash set, tset. Now, this is where I want you guys to be a little aware. Now, normally when I did the tunnel, what did I do? Interface, tunnel 1, IP address, 192.168.1.3, tunnel source, say E0/0, tunnel destination is 40.4, tunnel mode is IPsec IPv4, tunnel protection is IPsec profile, iprof. Now help me out. Where did I link my IKV2 profile in the previous example? Remember this? Inside the crypto map. Do I have a crypto map over here? What replaced the crypto map over here? What did I apply on the interface to tell it to encrypt? No, mode just changed it from GRE to IPsec. What did it tell? What did I put on that interface to tell it to encrypt? That replaces your tunnel protection IPsec profile, iprof. So iprof is the one that I link my, because if I do it like this, it's going to do IKV1. It's going to try to do IKV1. I want it to do IKV2. So that same set IKV2 profile command goes where? Under your IPsec profile. So what you did in the crypto map over here, same command needs to be done under the IPsec profile. That's the one that when you attach the IPsec profile to it saying, hey, listen, I want to encrypt it. When it goes to iprof, it says, oh, I want to encrypt using this IKV2 profile, IKV2, then it kicks the IKV2 process. And the last step, run a routing protocol. I'll just run EHRP. So phase 2, IPsec profile, tunnel, and then the routing protocol. Copy it and paste it to R3. Looks like it's good, but the tunnel will stay down until the other side comes up. Show interface tunnel 1 should be down. Good. How do I bring the other one up? Let's copy paste it now. There we go. So this one can remain the same. This one I'll change. R3, and I'll point to 30.3, which is the public address for R3. This again changes to 30.3. My IP address is 192.168.1.4. I'm on router 4, pointed to 30.3. The rest remains the same. This will go on R4. Let's bring it up. There you go. You guys can see the neighbor is already up. Show IP, EIGRP neighbor should be up over the tunnel. Show crypto IP2SA. It is ready. Show crypto IPsec SA. My packets are getting encrypted. What do you know? Ta-da! Repeat count of 100. So my numbers will go up. And that is Flex as well as SVTI. As I said, I'm going to give you a couple of videos in addition to that. This is a long video, but it has a lot of good stuff. On this particular day, this is also something that will help you understand what are the different things that I do in a particular class. So this is a more complicated, when you go through the video, these are the notes for that video. Thank you, Ulf. Hope you enjoyed it. So I'll send this out. Thank you. Thanks, guys. Great. So it's probably because what part makes it Flex VPN? Flex VPN, this is a simple example of Flex VPN. When you go through my video about that spoke to spoke, you'll see that. All right, Kenny? For sure, Bill. Hi, Mo. Why IOU over DNS? DNS gave me a lot of problems when they went to the newer one. So IOU, it was leaner for routing. So if you're doing a lot of stuff with the routers, IOU was better. Then the reason I'm not doing DNS anymore because EVNG came out and it gave me a lot more capability than GNS did. That's why. Okay. Thank you, Kenny. Thanks, Chris. You guys take care. You guys have a nice one and hope to see you in one of my classes. All right, take care. Thanks.